Hello everyone. Today we will be talking about Azure Web Apps, a very simplified view of what actually are Azure Web Apps, a little bit of backend architecture, and some use cases for utilizing Azure Web Apps. So the first thing that we will be talking about is what exactly are Azure Web Apps, a brief architecture of the Web Apps, the type of applications that are deployed using Web Apps, so some use cases for deployment, the technology flavors that are available for web apps, and what is the unique selling point, which is called deployment slot. So we will talk a little bit about that as well. So what are Azure Web Apps? Azure Web Apps are known as app service as well. It is a solution to host platforms. Basically, it is one of the most popular services that is available on Azure. It is defined on the classic platform as a service architecture model where the underlying infrastructure is abstracted from the end user. So developers can focus on creating the application and the platform, which is Azure in this case, takes care of running it for you. Why would anybody actually use Azure Web Apps? It is very easy for developers to get started and run applications within minutes on Azure. Expertise of real-world developers actually lies in creating applications and not in worrying about provisioning infrastructure to host the application. The app service does just that. It abstracts the provisioning of infrastructure, making it easy for developers to deploy their applications and see them running in production in little time. This takes away from worrying about the operating system and maintaining or patching of any software on the actual physical infrastructure. And as the load on the web app increases, the Azure platform takes care of adding more infrastructure to handle the load and handling of load balancing also within these added instances. It also provides redundancy, with Azure actually providing dedicated infrastructure to run web apps from anywhere in the world. The developers do not have to worry about hosting multiple copies of the application. And lastly, Azure provides an SLA of about 99.995% uptime for web apps. So if there's an issue with the platform, it is resolved by Azure, and the developers do not need to worry about spending any cycles in firefighting. Now we will talk a little bit about what kind of applications are suitable to be deployed as Azure Web Apps. So any existing applications that cannot be containerized and need to be migrated to the cloud are most popular use cases for Azure Web Apps. This includes any existing web applications that are containing the front end, APIs, or just any backend services. And think about this. For any smaller companies where there is no dedicated infrastructure team, the developers prefer to develop applications and use web apps for deployment, as it takes care of setting up the infrastructure and the front-end domain for any of these web-based applications. Thirdly, mobile applications and or logic apps, which rely only on logic to be complete a set of programs, are some of the best use cases for Azure DevOps. What is the architecture of web apps? App services actually have dedicated infrastructure provided by Azure, which is distributed globally. The main architecture contains of something called a scale unit. So we will talk about what this scale unit is. The scale unit is actually a collection of servers that run your applications. A typical scale unit can have about 1,000 servers. So building blocks of a scale unit contain a front-end server. So the front end is more likely a 7-layer load balancer, which is acting as a proxy, distributing incoming HTTP requests between different applications and their respective workers. Currently, the web app load balancing algorithm is a simple round robin between the set of servers allocated for a given application. These front-end servers stand in front of worker instances. These are called web worker instances. These are actually the backbone of the app service scale unit. An app service scale unit has several pools of workers already pre-provisioned and ready to host applications. Because the workers are already pre-provisioned and warm, all that needs to happen is for the application to be deployed on the worker. Once the app is deployed, the worker is inserted into the rotation and the front end can start allocating traffic to it. This whole process actually just takes a few seconds. Behind all of this is a shared content location. So as the name suggests, it is just a common shared server which is going to host all the content associated with websites. Example, anything that is in the app data folder or images or any other files in this location, and it can actually be accessed by a backend service called Kudu. If you see the diagram, all the instances of the worker role are connected to the shared content server and can have access to the data. And every time you decide to scale your application, Azure just adds more worker instances and starts adding them to the front end server. So scaling is not actually scaling all three of these, it is just going to scale your web worker instances. So what are the technology flavors that are available to host these web applications? There are three main technology flavors in which you can host your Azure Web Apps. The first one is Windows. So any of your applications that require a classic Windows operating system are deployed in Windows Web Apps. And every time you deploy an application in Windows, Azure actually provisions either a VM, which is dedicated to host your application, or a shared VM to host. Since it is a virtual machine, you can customize by installing multiple extensions. So extensions can be versions of technology or even third-party software. So if you in case you want something like a different version of .NET Core Profiler, you can specify that while running your Windows server, your web apps in Windows flavor. The next option you have is to run in Linux. When you say Linux, web apps are actually run as a container on a Linux operating system. Since they run as containers, there is no option to install extensions on that container. And what Web App Microsoft provides you is limited set of base images. So if in case you're deploying an application in Node.js, you have a predefined set of Linux container images available to you that you need to select in order to run your Node application. So you can only use the versions that are available or predefined in the Microsoft Azure console. The third option is to run them as containers. So any applications that you would have that can be containerized, or if in the case that you need any customizable Linux container, you can create your own containers and takes care and deploy them as an Azure web app. So what the developers only provide containers and the platform takes care of the orchestration. In this case, think of not having to install a full Kubernetes environment just to run one container, but taking your container and giving it to Microsoft Azure and asking your web app to take care of orchestrating this container. What is a unique selling point of Azure Web Apps is deployment slots. Deployment slots are live apps with their own host name, which are running on very similar infrastructure as your current application. Think of the fact that if in case you have a staging website and a production website and you want to run both of them in a similar architecture, you can have two deployment slots and two websites, one with staging.website.com and the other one as production.website.com. So what the benefit of doing this is that you can actually validate your app changes in a staging deployment slot before swapping it with production. And also you can route some of your production-based traffic to your deployment slot. So in case you just want to route 20% of the traffic to your staging environment, make sure that it is running properly and then swap it out. That is also possible. Deploying an application to a deployment slot first and then swapping it to production makes sense since all of those instances of the slot are warmed up before being swapped into production. This eliminates any downtime when you deploy your application. The traffic redirection is seamless and no requests are dropped because of the swap. You can automate this entire workflow by configuring auto swap and when pre-swap validation isn't needed. After a swap, the slot, which previously was the staging application, is now the previous production. If the changes swapped into the production slot are not as you expect, then you can go and perform the same swap immediately again to get your site to the last known good website. This is the reason a lot of developers actually get started with Azure Web Apps because they're easy to deploy and provisioning of the infrastructure is taken care by Azure. Thank you for listening. Take care.